Okay, so today's video is going to be about light, but the topic we will be studying about light today is separate. Today we will be talking about polarization in detail. Polarization in detail. Okay, so what is polarization? Um, Polarization is mostly used to decrease the amount of photons or to decrease the light reaching your eyes. Mostly polarization is used for glasses. Glasses. Okay, so it's used for glasses. What happens is that when the person's glasses, they are mostly in most glasses have it. When sunlight reaches the glasses, it it somehow makes a shade on it, and those shades, what they are, they're like dark, a little like I suppose gray black. So what is actually polarization? Polarization refers to the orientation of the oscillations of a wave, especially in the context of electromagnetic waves such as light, because we know that light travels in the electro. This is what it is. These are the arrows for electromagnetic waves. Electro electromagnetic magnetic wave. Look, the arrow, upper arrow and bottom arrow, they both together describe the electromagnetic wave. Okay, so then we have, while light waves are transverse and oscillate perpendicular to their direction of travel, the direction in which the electric field oscillates defines the wave's polarization. So what I mean by that is polarization can be categorized in several ways. One is linear polarization. The electric field oscillates along a single plane. Okay. First of all, let's talk about linear polarization. Okay, so when, let's suppose this one right now, this one is a horizontal polarized paper. Horizontal polarized polarized or polarized. Acha. So what happens that when this light electromagnetic wave passes through this polarization, only the horizontal, the vertical will stop. This is the vertical, not horizontal. Vertical. Okay, so this is vertical. Okay, so only the horizontal will now be seen, or vertical will be stopped. Or it's opposite. Sorry, it's opposite. Only the upper, these will be seen. That's it. Since they are horizontal, they won't be able to cross. Okay, so then after I look, then there is horizontal polarization. Now these can't travel through it. So when we look at the end, we have no light. Okay, this can be seen through an example. Okay, let's suppose this is a table. First, okay, this is what you call a polarization paper. This polarization paper is this is called 90 degree or 0 degree. 0 degree. So right now, if someone is looking from here and there's an object over here, let's suppose this object is apple. Okay, this person will be able to see that apple, but How he will not be able to see it's that if we put the polarization paper in this way, or wait, let me draw it properly. This way. Now it's horizontal. So that means if this is how it is, then after going through it, only these will remain. These will be cancelled. They will be stopped, blocked. So now again here 50% is cut. 50% of the light is gone. Here again, now this is a horizontal polarization, but these are vertical lines, waves. So what will happen? Again, it will stop it, block it, and it will not let the light go through. So 50% again. So together, what do they make? 100% polarization effect. So that means this object after horizontal and vertical polarization, the light will not go through. But there is an alternative to how we can prevent this. But it's also on probabilities. What we do is that, okay, so light is photons, so I can say let photons go through. Let some photons go through. So what will happen? This will stop. Okay, only these will travel now. Now, what we will be doing is that we will be adding a third polarization paper. And this paper will be in a special form. It will be at an angle. And this angle is known as 45-degree angle. Now, 50%, but this 45% changes everything. Now, sum of light, maybe let's suppose 4 passes, 2 of them will go through. What will happen? When these two will go through, these two will go through. This two will go through. Now here we have 2, 3. Now this will change the effect. Now from here, some will go through. Let's put 3 go here, 2 will reach here. If this is 5, this is 3, this is 5, this is 3, and this is 2. So this is causing now the percentage effect changes. Here you can say 25%, 40%, 45%, 25%. So it's probabilistic. Now 45, 25 plus 25, how much is this? 50. And 50, so means these two can change. So what I'm trying to say is that we can prevent the object from being fully invisible to we can see some of the object. Okay. So then when we talk about, what else can we talk about? We have, so this is how the shades work. This is how the system of the shades is. Here, shades have these, and these, and together they make these shades which lets some of the light go through so that we can see, or those people who wear them see. Okay, then then what do we talk about light? Then we have something for known for light is refraction. What is refraction? So when we talk about refraction, first of all, let me write the formulas of refraction. Refraction has two formulas: n equals sine of theta over sine of theta nahi, sine of I over sine of R. I is incidence angle and R is refracted angle. Okay, N is refractive index. We call it refractive index. Mostly the formulas. Then we have V equal VG, VC over VG. However, VC here is constant. VC is 2997924 meter per second, which equals to 3 times 10 to the power 8 meter per second. Okay, now what do we have now? If we have the speed, okay, let me first tell you what is refraction. So what I'm talking about is that when light from another medium, this is light in air, so what will happen? Light, when it's traveling towards the normal, and the moment it will reach this medium, and if that medium is denser than the medium before it, it will curve towards the normal. So we can say this theta and this theta, this is air and this is glass, or we will say water. So I will say that sine A and sine W. So sine W is less than sine A, as the speed of light in air is more. As the speed of light in air is more, this will prevent the speed. And one more thing here, if there's speed of light, there's a change of speed of light, there will be change of direction. Okay, so since it's first it was going this like this, and then it curved towards the normal, which made it also change direction. Okay, one more thing here, wavelength will change and speed will change. Oh yeah, one more equation is made up here, which is v equal f of pi, or lambda is wavelength. And so then what will happen here? This will change, but one thing is which will remain constant, which is frequency. Frequency will not change. It's a constant value even when crossing medium. Yes, it's when while crossing medium. Constant. Okay. So then what do we talk about? We talk about yeah. When we talk about n equal VC over VG, and n equals sine theta, which is I, over sine theta R. Okay. So then we'll combine these two equations. VC over VG equal sine theta I over sine theta R. Okay. Even this can be used to find either of the. We already have V. Maybe they will give VG and the sides are not given, and vice versa. So this can also be one equation when we are given an angle, a certain angle. Like let's suppose if I illustrate, if I can illustrate, let me illustrate that. Okay. So let's suppose we have this theta and we have this theta, plus we have the speed of light in air, which is 3 times 10 to the power 8. We all know that. So we can use this theta I and theta r and this to calculate speed of velocity in glass, speed of light in glass. So this is refractive index. Okay, then when we talk about more about the refractive index, here we can say one more thing. There's something known as critical angle. What is critical angle? Critical angle is point at which the angle which is made with the angle which is made by the light with the normal, if that angle is greater than a certain angle of that material, the light will fully reflect. So what I mean is that critical angle is the point at which the light will be at a perpendicular angle to the normal instead of going at an angle outside that medium. So then we can say n equal 1 over sine c. Sine c is the critical angle. So what does this mean is that any angle below this, above this will cause the object to fully reflect, and this the light to fully reflect, and we call this T R TIR. What is TIR? Total internal reflection. What I mean by total internal reflection? 100% of the light is reflected. So here, then back normal. Okay, what else do we talk about here? Critical angle, an angle after which on increasing will make the light to do total internal reflection. So the more the increase, the more the reflection inwards. The more the increase, the more the reflection inwards. So so on. Okay. So this is what happens in the optical cables, optical fibers. Total internal reflection is used for light to travel through it, in it. Yeah. These angle, they are greater than critical angle. Critical angle. Okay. So what else can we talk about here? This all is, yeah, that's it. This all is what we have. Thank you.